Hello friends, welcome to Creative Minds YouTube channel. In this video, I am going to explain geometric progression. A geometric progression is a sequence in which the ratio of every term to its preceding term is fixed constant. Geometric progression is a sequence in which the ratio of every term to its preceding term is a fixed constant. And this fixed constant is called common ratio, which is denoted by the letter R. I will explain through an example. 2, 4, 6, 2, 4, 8, 16 up to 64. The ratio between any two terms 4 by 2 is a 2 and 4 and A3 by A2 is also 2. A4 by A3 is also 2. So the ratio is 2, which is constant, so which is in AP. Next example, 1 by 2, 1 by 4, 1 by 8, 1 by 16. Here also 1 by T2 minus T1 or A2 minus A1 is 1 by 2. A3 by A2 is also 1 by 2. So the ratio is 1 by 2. So R is 1 by 2. Here 3 to the power of 1, 3 square, 3 power 3, 3 to the power 4, so on. Here also the ratio, common ratio is 3. So 3 square by 3 to the power of 1 is 3. 3 cube by 3 to the power of 2 is 3. So on up to. So the ratio is a constant, which is 3. So which is also in GP. Now a GP which has a first term and the ratio, first term A and R, then general form of GP is AR to the power of first 2 AR up to AR to the power of n minus 1. Then how to find nth term in GP? The formula is like this: AN is equal to A into R to the power of n minus 1. N term of GP is AN is equal to A into R to the power of n minus 1. Let's see the remarks. Remark number 1. To find sum of nth terms of GP when first term A and common ratio R is given. The formula is like this: Sn is equal to A into 1 minus R to the power of n divided by 1 minus R. For all R is less than 1. When R is less than 1, that is common ratio in any GP is less than 1, to find nth sum of nth terms in the GP, we have to use this formula: A into 1 minus R to the power of 1 divided by 1 minus R. When R is greater than 1, that is common ratio in GP is greater than 1, then we have to use this formula to find the sum of n terms in GP. That is Sn is equal to A into R to the power of n minus 1 divided by R minus 1. When R equal to 1, that is common ratio is equal to 1, then Sn is equal to n into A. That is for examples in GP. Now, how to find sum of infinite terms in GP? The formula is like this: Sn is equal to, S infinity is equal to A divided by 1 minus R. Here, S infinity means sum of infinite terms and A is first term and R is common ratio. Now, any three numbers in GP can be written as A by R, A. This is used in some problems I will explain later. This and the next remark is five numbers of GP can be written as a by r square, a by r, a r square. This is also used in some problems, so I will explain later. Okay, now move on to some problems. These are about some remarks and definition of GP. I think you understood. Now move on to problems related to GP. Find the nth and 20th term of GP given that 5 by 2, 5 by 4, 5 by 8. 5 by 2, 5 by 4, 5 by 8 is is given. So a value of A is 5 by 2, first term 5 by 2. And R is we can easily calculate by T2 by T1, that is equal to 5 by 4 divided by 5 by 2, that is equal to 5 cancel 1 by 2. Now we have to find nth term and 20th term. So we have the formula an is equal to a into n minus 1, a into r to the power of n minus 1. So an is equal to value of a is 5 by 2 and r is 1 by 2 whole to the power of n minus 1. So 5, 1 to the power of n minus 1 is 1 and divided by 2 to the power of 1 is there and 2 to the power of n minus 1 is there. 2 to the power of n minus 1 plus 1, so 2 to the power of n. So value of an is 5 by 2 to the power of n. Now we have to find the 20th term. So A20 is equal to, use this one. So 5 by a to the power of 2 to the power of n is there, 2 to the power of 20. So 20th term of this GP is 5 by 2 to the power of 20. Now move on to next problem similar to above problem. Find the nth and 10th term of GP 5, 5 square 125. So value of A is 5 and R is 25 by 5, that is equal to 5. So we have the formula an is equal to a into r to the power of n minus 1. So an is equal to value of a is 5 and r is 5 only. Then n minus 1, 5 to the power of n minus 1 is there. Here 5 to the power of 1 is there. 5 to the power of n minus 1 plus 1 is 5 to the power of n. So now we get an value, an is equal to 5 to the power of n. So we easily calculate nth term, that is a10 is equal to 5 to the power of 10. Now move on to next problem. In a GP, third term is 24 and sixth term is 192. Find 10th term. The given that third term is 24 and sixth term is 192. We have to find n 10th term. So a10 is equal to, we have to find. We know that A3 is equal to AR square according to general form of GP. AR square is equal to 24. Take it as equation number 1. And A6 is equal to AR to the power of 5. So that is equal to 192. Equation number 2. Divide equation 2 by equation number 1, then we get AR to the power of 5 divided by AR to the power of 2, that is equal to 192 divided by 24, that is equal to 8. So R cube, AA cancel and R to the power of 5, R to the power of 2 is there. So 2 cancel, remaining thing is a r to the power of 3, that is equal to 24 ones are 24 eights are that is equal to 8. So r 3 r to the power of cube r to the power of 3 is equal to 8. So r is equal to 2. Now we have to find A10. So according to general formula of GP, we know that A10 is equal to AR to the power of 9. A10 is equal to AR to the power of 9. So A10 is equal to a, we have to find a, right? We don't know the value of a. So here we have AR square is equal to 24. So AR square is equal to 24. Now we have find we already find R is equal to 2. So A into R square, that is equal to 24. A into R square 2 to the power of 2, that is equal to 24. So A is equal to 24 by 4, that is equal to 6. Now we got the value of R and got the value of A. So we can easily substitute in this formula. So A10 is equal to AR to the power of 9. A10 is equal to 6 into value of A is 6 and R is equal to 2. So R to 2 to the power of 9. So 2 to the power of 9 into 6, that is equal to 3072. So value of A10 is 3072. So 10th term is 3072. Next, move on to the next problem. Which term of the following sequence? 2 to the power of 2 into root 2, 4 up to 128. They given last term. We have to find which term is 128. We have to find n value we have to find. Given that a is equal to 2 and R is equal to T2 by T1, that is equal to 2 root 2 divided by 2. 2 cancel, the remaining thing is root 2. So AN is also given, AN is equal to 128. We have to find N. So AN, we have the formula AN is equal to N into AR to the power of N minus 1. 128 is equal to 2 into A value is 2. R to the power, R is root 2. Root to the power of N minus 1. So 128 divided by 2 is 64, that is equal to root to the power of N minus 1. So 64 we can write that as root 2 to the power of 12. So is equal to root 2 to the power of n minus 1. 64 2 to the power of root to the power of 12. So base is same, so power also same. So 12 is equal to n minus 1. So value of n is equal to 13. Now move on to next problem. 1 by 3, 1 by 9, 1 by 27 up to 1 by 19683. So 19,683. We have to find value of last term is this one. So we have to find value of n. Same problem, same as above. So a value is given. A is equal to 1 by 3. R is equal to T2 by T1. 1 by 9 divided by 1 by 3. 1 cancel. 9 threes and 3 ones. So when it goes upper side, 3 1 is go upper side numerator and 3 becomes denominator. We know this one. So R is equal to 1 by 3 and AN is equal to the given AN is equal to 1 by 19,683. So AN is equal to AR to the power of n minus 1. 1 by 19683 is equal to 1 by 3 value of A into 1 by 3 to the power of n minus 1. 1 divided by 19,683 is equal to 1 by, here 3 is there, 3 is there, 3 to the power of n, 1 to the power of 1 to the power of n minus 1 is 1. So 3 to the power of n minus 1, 3 to the power of 1. So 3 to the power of 1. 3 to the power of 1 to 3 to the power of n minus 1. Here minus 1, 1 cancel. So 3 to the power of n. So now 1 by 1, 19,683 is equal to 3 to the power of 9 is equal to 1 by 3 to the power of n. So base is same, So power also same. So n is equal to 9. Now move on to next problem. Find what value of x numbers minus 2 by 7 my x minus 7 by 2 are in GP. They given that minus 2 by 7 x minus 7 by 2. So now we have to find value of x. So by the definition of GP, x by minus 2 by 7, that is equal to minus 7 by 2 divided by x, that is the ratio of any two terms, any term and its preceding term, any term and its preceding term is constant. So definition, by the definition of GP, we can write this. So on cross multiplication, x into x square, minus 2 by 7 into 7 by 2, 2 cancel, plus into minus plus 2 sevens are 14 and 7 twos are 14. So 14 cancel, or 2 cancel, 7 cancel, minus into minus plus. So x square is equal to 1, x is equal to root 1. Root 1 value is 1, so x is equal to plus or minus 1. Very easy problem. Now move on to next problem. Evaluate summation 2 plus 3 to the power of k, where k runnings from 1 to 11. So summation means sum of this. We have to find sum of this number. So summation is running from 1 to 11. So let's separate each term. 2 plus 3 to the power of 1 plus 2 plus 3 to the power of 2. Because k is running from 1 to 11, we have to expand this. So plus 2 plus 3 to the power of 3 plus 2 plus 3 to the power of 4, also on up to 2 plus 3 to the power of 11. So here 2, 2, 2, 2, 2, 2, we can take 2 outside. So 11 times 2 plus 2 plus 2 plus 2 is plus 3 to the power of 1 plus 3 to the power of 2 plus 3 to the power of 3, 3 plus 3 to the power of 4, so on up to 3 to the power of 11. So this one, take it as 2 times 11, and here this is in geometric progression. So a value is 3 to the power of 1, so that is equal to 3. R value is 3 to the power of 2 divided by 3 to the power of 1, that is also 3. R equal to 3. An is also given. An is equal to 3 to the power of 11. So here R is greater than 1, so we have the formula sum of nth term. So we have the formula Sn is equal to A into R to the power of 1, R to the power of n minus 1 divided by R minus 1. I will explain in, I have explained in last video. So that is equal to 3 into 3 to the power of n minus 1 divided by 3 minus 1. That is equal to 3 into 3 to the power of n minus 1, 3 minus 1 is 2. So Sn is equal to 3 into 3 to the power of n minus 1 divided by 2. Here n value is given, that is equal to 11. So the whole expression becomes 2 into 11 plus 3 into 3 to the power of 11 minus 1 divided by 3 minus 1. 2 11s are 22 plus 3 to the 3 into 3 to the power of 11 minus 1 divided by 2. That is equal to 2 is LCM here. So 2 22s are 44 plus 3 into 3 to the power of 11 minus 1 divided by 2. That is equal to, so 3 into 3 to the power of 11. So 3 to the power of 12. 3 into 1 is 3. 44 minus 3 is 41. 41 plus 3 to the power of 12 divided by 2. That is equal to 44 plus 3 to the... So, this is the last answer. So, next few problems is there. I will explain in next video. If you like this video, subscribe our channel Creative Minds and hit the bell icon for further notification. Thank you.